Good day, math learners. In this video, you are going to learn linear inequalities in one variable. So let's begin. When we say inequality, it states that two expressions are not equal. The solution set of an inequality can be illustrated in a number line and can be written in set builder and interval notations. So, here are the following symbols for inequality. We have the not equal to, which means is not equal to. We also have the greater than symbol, less than symbol, and the greater than or equal to, and the less than or equal to. We also use these graphing symbols, or when we graph linear inequalities, we have for the greater than or less than, we use the open circle for the graph, and for the interval notation, we use the parentheses. For greater than or equal to and less than or equal to, for the graph, we use the shaded circle, and for the interval notation, we use the square braces or the brackets. Now, if the given is an equation, we have solution, or we have one solution. But if the given is an inequality, we have a solution set. When we say solution set, it is a set of numbers wherein each element, when substituted for the variables, results in a true inequality. The solution set of any inequality can be illustrated on a number line. So, for example, we have x is greater than 4. In this example, when we graph this, first we need to locate 4, and since we are using a greater than symbol, we will use an open circle at 4. This open circle indicate that 4 is not included. Now, for the translation, we have the set of numbers greater than 4, and for the solution set, all real numbers greater than 4. So we have 5, 6, 7, so on, and the numbers between them. So when we write our interval notation, since we are using a greater than symbol, we will use a parenthesis. So parenthesis 4, comma, positive infinity, and then close parenthesis. Let's have another example, which is x is less than or equal to 5. So as you can see in our graph, since we are using a less than or equal to, there's an equal sign below the less than symbol, so that means we will be using a shaded circle, which means that 5 is included. Now, since the value of x is less than 5, that means our arrow will be going to the left because it's less than. So for our translation, we have the set of numbers less than or equal to 5. And the solution set, we have all real numbers less than or equal to 5. And our interval notation, since the arrow is going to the left, we will write the negative infinity first, comma, and then 5, and then we should use the square bracket since 5 is included. Now this time, let's learn how to graph compound inequalities. When we say compound inequality, it is the intersection of the graphs of the separate inequalities. So it's like combining two graphs of linear inequalities. So for example, we have here negative 1 is greater than x and greater than or equal to negative 3. Or it can be read as x is less than negative 1 but greater than or equal to negative 3. Now, the first thing that we need to do is to graph the two separate inequalities. So first, let's graph x is greater than or equal to -3. So that means we will use a shaded circle and it's going to the right. While the second inequality, we have x is less than or yeah, x is less than -1 or -1 is greater than x. So that means we will use an open circle and it's going to the left since x is less than -1. Okay, now by graphing compound inequalities, we will be combining these two graphs. So just write first the -3. Use a shaded circle. Just copy the circle that we have used in the first graph, and also an open circle at -1. And then just follow the direction of the arrow and shade those parts. So by combining these two separate inequalities, translation, we have the set of numbers greater than or equal to -3 but less than -1. And for the solution set, all real numbers greater than or equal to -3 but less than -1. And for our interval notation, we have, since we used a shaded circle, we will use a bracket, -3, comma, -1, and then open circle, meaning open, we will use parentheses. Now let's have another example. We have here x is greater than 2 but less than 5. So first step, let's graph x is greater than 2. So we have an open circle at 2 and then the arrow is going to the right since it is greater than 2. And next, for the second graph, we have an open circle at 5. And since we have x is less than 5, our arrow is going to the left. Now let's have the compound inequality of these two graphs. So first, just copy the circle, the open circle at 2 and the open circle at 5, and then shade the part where the arrows are facing. So we now have, for the translation, the set of numbers greater than 2 but less than 5, and for the solution, all real numbers that are greater than 2 but less than 5. And for our interval notation, since it's an open circle at 2, we will use a parenthesis 2, comma, and then open circle at 5, so we will also use parentheses.